Hey friends, I'm going to go ahead and call today Thankful Tuesday because I'm just so thankful that I made it through Monday. So here we are again for another Number Corner video where today is December the 8th and we are going to talk more about these fancy shapes that we have going on here on our calendar grid. And we're also going to talk about some multiples, so hopefully you remember what a multiple is. Let's start though by first looking at today's calendar marker. We know we have shapes that have an area of 5, a perimeter of 12. They have varying number of sides. Some of them have lines of symmetry. Some of them do not. They have parallel lines. They have perpendicular lines. That's what we know so far. Today, our job is going to be to see if we can describe or name these shapes. So here is today's. Let's see if this one still holds true for what we know. 1, 2, 3, 4, 5, area 5. Check the perimeter. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Still 12. That's amazing. So let's fill that in on our observation chart. So we know that there has a perimeter of 12 inches. We know that there's an area of 5 square inches. What we don't know is the number of sides. So let's figure that out. Now, when we count the number of sides, it's different from counting perimeter. So I'm just going to remind you, it's literally like counting to see, so you can name a shape. Okay, so hexagon has 6 sides, octagon has 8 sides. So we're counting the sides, not each individual side length, okay? So this is a side, 1 side, 2 sides, 3 sides. This is a side, 4 sides, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 sides on our shape for today. Okay, do we see any lines of symmetry? Yeah, I think we have at least one line of symmetry here. So let me just go ahead and put 1 there. And we know that there are there some parallel sides? Yeah, this side's parallel to this side. We got a parallel side here. We got a horizontal side here, as well as here and here. So I'm going to put yes. And do we have any perpendicular sides? Yes, we do. So I'm going to tell you something. I'm actually going to tell you what this shape is called. And then you're going to have to use your observational skills to figure out a definition for this shape. Now, first, tell me, what is a shape called that has 5 sides? Right, it's a pentagon has 5 sides. So there's a part of that word that means 5, just like in hexagon, hex means 6. In a septagon, sept would mean 7. Octagon, oct means 8. So pentagon means 5. Pentagon has 5 sides. So we're going to take that term pent, that beginning, that affix, that prefix, piece of a word, and we're going to add it to another word to create a new word. And that new word is pentomino. Can you say pentomino? Great. We have pentominoes. That is what these shapes are called. So now what I want you to do is we are going to look at some of the pentominoes and we're going to have to figure out what in the world a pentomino is. What does it have to, where's 5 come into play, and how else might we be able to describe them? So here's a page of some pentominoes. It shows you what pentominoes are. So these are pentominoes. These are not pentominoes. Obviously, this is a space here, space, space, space. Some spaces going on. So just take a second to study that and see if you can come up with a definition for a pentomino. And if maybe you can't come up with a definition, at least figure out what's similar with these that's different with these. Yeah, that's where the 5 comes in. They all have an area of 5 square units. So that's the pent, 5 square units. They have to have 5 square units to be a pentomino. What else do we know? just by looking at these shapes compared to these shapes. Do you notice that in the ones that are pentominoes, they're all connected by edges, like a whole edge is connected. There's no spaces in between. They have to be connected by at least one edge. And look at these. This one's not connected by an edge. This one's not connected by an edge. This one's not connected by a full edge. So that can kind of help us with our definition of a pentomino. So let's see if we can make a definition for pentomino. Pentomino is a shape that has 5 sides. And those 5 sides, those 5 squares are all equal. They're congruent, okay? So a shape that has 5 congruent sides or 5 congruent shapes, these are the same size, same shape. They're squares, so 5 congruent squares, and they have their edges touching. So it has at least one of its side common with another square. So we can't have corners touching or half of an edge. It has to have a full edge that's touching in order for it to be a pentomino. So let's look at these pentominoes. And you can open up to the page, What is a Pentomino, in your Number Corner journal. So I will give you a moment to do so. It should be on page 35. All right. So which of these is a pentomino? And I'm going to circle them, or I'm going to attempt to circle them. Is this a pentomino? Wrong answer, because we know that they have to be touching by an edge. Is this a pentomino? Yes, it is. Whoops. And I'm trying to make a square here. Let's try that again. There we go. This is a pentomino, so you might want to circle that. Is this a pentomino? Let's see if it has, oh, we didn't check this. Does it have 5? Yeah. This one have 5? Yeah. And they have some edges. At least one edge is connected to another square. All the same shape, all the same size. This is one a pentomino? No, that one's easy because they are not connected at all. Okay, so we just have 5 squares in forming like a circle of some kind. So I want to see if you remember what we said about a pentomino, and I want you to write your definition of a pentomino in your number corner journal right now. See if you can recall what we just talked about, or if you can put it in your own words. Right. So hopefully you wrote something along the lines of, a pentomino has an area of 5 square units. So it's 5 shapes, congruent shapes that are squares. And they have to have at least one side touching. We call that an edge. So at least one edge has to be touching another one of those shapes. Now, number 2 says you can use some squares or tiles. Maybe you can even use grid paper and see if you can outline some to find as many pentominoes as you can. How many different pentominoes are there? I'm not going to give you time during Number Corner during this video to do so, but if you have time after this video and you're interested to see if you can challenge yourself to figure out how many pentominoes you can discover, then please do so. And if you do, make sure you snap a picture of it or show your teacher so that she can see all the hard work that you're doing for Number Corner. All right? All right. Well, now we are going to move on to our multiples. What is a multiple? What is a multiple? Do you remember? All right, great. Multiples, when you're counting by a certain number, every number you land on is considered a multiple of that number. So we have here listed multiples of 2, multiples of 3, 6, 4, 8, 5. We also have multiples of 10. I need to add this to my collection here. Multiples of 10 with a black X underneath. So here are multiples of 10. And some of them have only one. They're only we only recognize them one time. And some of them have like more than one. Like 2 has a lot of multiples. 4, everything that's a multiple of 4 is also a multiple of 2. Things that are multiples of 8 are also multiples of 4, and that's because of that doubling effect. Okay? If you have multiples of 3, then all the multiples of 3, or I should say this, multiples of 6 are also multiples of 3. Multiples of 10 are also multiples of 5. Today we're going to talk about multiples of 7. Now, if you're anything like me, 7s are not necessarily your favorite multiplication or timetable fact to memorize. And so when we talked about multiples of 5, we kind of talked about how you can use a multiple of 5 to figure out multiples of 7 or multiplication problems that have a 7 as one of the factors. And so today, we're just going to outright mark the multiples of 7. So what do you think a multiple of 7 is? Yeah, you can count by 7s, or at least the first few 7s. Let's start. 7, 14, 21. So we can at least maybe get to 21. Okay, so do you think that some of the multiples of 7 are already going to be marked? And if so, which ones? Well, we heard 14 already. We heard 21, and obviously those ones are already marked as a multiple of 2 and a multiple of 3. 7's not marked yet. And we also know that numbers that are not marked yet or only have one mark, it means something. And I wonder what it's going to end up meaning when we get to the end of all of our multiples. I'm going to say we are going to mark our multiples of 7 using a black star. Now, Mr. Mel probably can't draw stars very quickly, so I'm going to do my best, but I'm going to put a black star above the multiple of 7. So let's start. We would count by ones, normally in a count around in the classroom, and we'd whisper the numbers that are not multiples, and we would shout out loud the numbers that are multiples. But for the first few, since we kind of already went through them, I'm going to go ahead and mark them. So we know we have 7 is a multiple of 7. 7 times 1. We know we have 14 is a multiple of 7. And we have 21. But some of you may have some trouble continuing to just count outright by 7s. So we are going to start at the number 21, whisper count, and then when we get to a multiple of 7, we'll shout it out loud, okay? So far, we've marked how many? 3. And of those 3, only 2 of them were already a multiple of another number, right? Okay, so here we go. We are at 21. Now we're whisper counting. Count by 7s. 28. You see how I did that? And so you may need to do the same thing. Keep track of counting. How many times you counted on your fingers, and when you get to the 7th one, we're shouting it out loud. It's interesting. 28 is a multiple of 7, yes. It's also a multiple of 2, and it's a multiple of 4, which we know that anything that's multiple of 4 is going to be a multiple of 2. So that's not really that shocking. Let's keep going. So 28, we have 29, 30, 35. Ooh. So we've marked some multiples of 2, some multiples of 3, some multiples of 4, some multiples of 5. Now also our multiples of 7. That's interesting. How many more multiples of 7 do you think we'll have when we finish counting up until 100 on this number line? So far we have 5. Do you know that 7 times 5 is 35? So you could use this number line to help you solve some problems that you don't know. Yeah, you can count. Here's 1 7, here's 2 7s, here's 3 7s, here's 4 7, oh, and 7. So this was 1 7, 2 7, 3 7, 4 7s, and then 35 would have been 5 7s. So how many do you predict will we have when we finish? Guess let's see. Do you think it's more than 10? What was 7 times 10? 70. So we would still have more, right? All right, let's keep counting. So 35, 42. Let's keep going. 49. Oh, we found one that doesn't have a multiple. Another multiple. All right, let's keep going. 56. So then I wonder what times 7 gives us 56. Now when we were at 35, that was 5 7s. So you get 8. 7 times 8 is 56. Yeah, are you figuring out how to now multiply using multiples? I sure hope so. Let's keep going. 63. 70. So how many have we marked so far? If you were paying attention, you should know it right off top. Good. We marked 10 so far because 7 times 10 is 70. We're getting very close. We're almost there. Let's continue. 77. Keep going. 84. So how many is that? We had 10. We just added 2 more, so that's 12 multiples so far. So did anybody guess more than 12? Hopefully you didn't get 20. Right. 91. Do you think we can fit one more? I think so. 92. 98. You guys did it. We marked the multiples of 7. So now, do 7s have a lot of factors? I also want you to think, if you don't know a 7's fact, what could you do? What strategy could you use? I want you to be thinking about that because that's really important for you to understand and to know how to do, especially if you're map testing or when you take the end of the year state test or even classroom tests, because you need to know your multiplication facts. So we're doing all this so that you guys can see multiples, you understand what multiples are, and then you can figure out how you can use them to help you solve problems that you don't know. Great job today. I'll see you back again tomorrow. Have a great afternoon. Stay safe.